Right, yeah, my name's Nick. I work at a company called Shibstead, and I work on the platform team, where we mostly look at building code solutions to make engineers more productive. So I'm going to talk about a library I've been working on for the last few months called Layout. I'll start by telling you why we built it, and then I'll tell you what it is. So building UI for iOS is hard, and I think it's something that's gotten harder over the last few years as we've seen a sort of proliferation of different device form factors and other things have changed. We have to deal with dynamic content, so that means the Photoshop document or sketch file that your designer gives you doesn't necessarily reflect what you're really going to see on screen. Maybe there'll be localized text or different content. We've got multiple devices and orientations to deal with, and it's kind of gotten beyond the point where we can just hard code layouts for a bunch of different sizes. Potentially you're going to be dealing with animated interactions, so again, not static designs. And the design tools that designers use are quite different from the tools that we have available as developers. You can't just take a design and sort of somehow run it in your app. The solution that Apple has given us really since the inception of iOS, maybe even before, was Storyboards and AUTOLAYOUT. So Storyboards provide you this interface for laying out your interfaces, and AUTOLAYOUT is the solution for handling dynamic sizing. So there's some good things about Storyboards. They're kind of WYSIWYG. What you see is what you get, sort of. They're declarative. What do I mean by that? So you're describing what you want things to look like rather than describing sort of a set of steps that will be taken to build your UI. They're data, not code, so they're packaged separately from the code in your app, and you sort of don't need to debug them in the same way. And you have a fairly rapid edit cycle, so you can make a change in your layout in your storyboard, and you can see the effect right away using the WYSIWYG interface without having to recompile your app. The sense in which it's only WYSIWYG sort of is that there's very limited sort of control of data binding. So what you see may not actually be what you get once the app is running and you've got dynamic data coming in. What's bad about them? They're an opaque proprietary format, so you can look at what the what Interface Builder produces for the storyboard, and it's kind of XML, but it's not really human readable. It's full of machine-generated identifiers. I don't know if that format's actually documented anywhere, but I certainly have no idea what's going on there. That makes it hard to collaborate on a storyboard if you have a bunch of different developers, and we have quite a large team of developers working in different time zones. It's very difficult for you to concurrently work on the same storyboard. There's limited reusability, so if you have maybe a label with a particular font and a color somewhere in your storyboard and you want to reuse that in dozens of places, you pretty much have to copy and paste it and hope that the designer doesn't change the font next week. Yeah, we've all been there. It's hard to refactor, so again, the same issue. If you need to make a sweeping change across all of your storyboards, you're pretty much just going to either have to go in there and sort of do find and replace and hope it works, or just throw it all away and start again. And it's hard to share data with your code. So if you have, you probably have a bunch of nice color constants, or maybe you've set all of the metrics up as constants on CG float or something in your code. If you want to use those values in your storyboard, again, you're back to copying and pasting. There's no way to share that. So what are the alternatives to using storyboards? Well, the obvious answer is to do all of your layout in code. I know a lot of people do that, and that's fine. You lose a lot of the benefits, though, of storyboards. You don't have WYSIWYG anymore. You've got to recompile every time you make a change. Or you can use third-party tools. An extreme example would be React Native, so you just rewrite everything in JavaScript. Again, it's an option. It's not everybody's favorite. Let's talk about AUTOLAYOUT for a bit then. So AUTOLAYOUT replaced auto-resizing as the way that we do our layouts these days. What's good about AUTOLAYOUT? It's declarative. So auto-resizing involved typically writing a lot of code inside layout subviews, and that's code that had to be executed procedurally. It could have bugs in it. It behaves differently under different circumstances. Declarative is generally better. It's much easier to reason about. And AUTOLAYOUT is very powerful, so it can do a lot of things that were either difficult or impossible or close, a lot of work with auto-resizing. auto-resizing masks were very limited in terms of handling things like a label whose text size might change, and AUTOLAYOUT has solutions for that. What's bad about AUTOLAYOUT? It's complicated. It has a very steep difficulty curve. I still wouldn't say that I really understand it after years of using it. It can be very slow. So AUTOLAYOUT uses a recursive algorithm for resolving your layouts, which often involves kind of taking multiple passes to figure something out. And that can result in strange, unexpected slowdowns. Particularly, people have had trouble with things like dynamically sized table cells. It's hard to reason about. So related to the same thing, you have a situation in AUTOLAYOUT where maybe you have two different constraints on the same parameter with different weights that kind of, it has to sort of resolve that by sort of comparing the weights and seeing which one wins in a fight. And it can become very difficult to understand what's going on there and kind of work out what the end result of your layout is going to be. And it's also hard to change. So I'm thinking mainly in the storyboard context. If you have like a bunch of constraints around your layout and then you want to add a new view somewhere in the middle, you've got all of these kind of interlocking constraints and you have to add these new ones and break some and connect some old ones to new places, and it's kind of spaghetti, and often you just end up deleting it all and starting again because it's easier. So one of my favorite quotes from Alan Kay is that simple things should be simple and complex things should be possible. So this is a principle for API design, basically. It says that if something is conceptually simple, the code to implement it should be simple. And if something is complex, then it shouldn't be simple, but it should at least be possible. I'll give some examples of how AUTOLAYOUT matches this requirement. So here's a simple thing, like the most basic thing you can really do. You've got a view and you want it to fit inside another view. And I mean, this is a lot of code to do this with AUTOLAYOUT, right? You have to set up 4 separate constraints in code. That's like a complicated line of code you have to write with loads of stuff in it. And this is the very simplest case. You can compare that to what you used to have to do with auto-resizing. To me, this is much more simple, right? What you're really saying is you want the width and height to be flexible, and that's exactly what auto-resizing gets you to do. A slightly more complicated example here. I've got 2 labels. I've hard-coded the text here, but in the real world, that text might be localized. You don't know how big it's going to be, so that has to be resolved at runtime. So you're positioning 2 dynamically sized elements next to each other. And that involves a little bit more code in AUTOLAYOUT, but it's not that unreasonable. This was also slightly simpler in the auto-resizing mask way of doing things, but a key difference here is that this code is not declarative. This is procedural code. So you have to call the size to fit function, and that's not like a sort of fire it once and then it'll just keep resolving itself. You have to basically call that manually inside layout subviews every time you need it to happen. That introduces all kinds of problems, like what happens if you call it too early before the views have been set up? What happens if something changes and you forget to call it again? So that's bad. So what are all the sort of alternatives we have to AUTOLAYOUT? Well, rather than using the very verbose kind of API for AUTOLAYOUT, you can use something called VFL, Visual Format Language, which is slightly more elegant. There's also a bunch of third-party open source libraries that provide DSLs, domain-specific languages, which are kind of alternative APIs for AUTOLAYOUT. And there's another solution which I've built called expressions, which I'm going to talk about in a minute. In short, expressions are a runtime expression library, like a runtime code evaluation, but critically they're not using JavaScript. This is a pure Swift solution. So I'm going to demo this for you now because it's easier to describe, easier to show than to describe it. So I'm going to build a very simple Hello World app. Last time I tried to do this, everything that could go wrong did go wrong. So I'm hoping it will go a bit smoother this time. So I've started with basically an empty project, just a standard project template. The only things I've done is I've imported the layout library, and I've changed the base class of my view controller to layout view controller. So the way that layout works, you can do everything in code, but you don't get the full advantages of doing it that way. The preferred way to build your UI is to use XML. So I'll show you what that looks like. So first of all, I have to load my XML file. So there's a bunch of different ways of doing this. I'm going to use a form of load layout named. Give me those parameters. If I run this, hopefully we'll see it. Okay, so we've got a blank screen, which I think is what I was hoping for. So we've got an empty XML file here, and I'm just going to add a label, UI label, if I can type. Okay. I've messed up my maths there somewhere. Okay, that looks better. So there's quite a lot going on there, so I'll talk you through it. Okay, so first of all, you probably noticed I didn't have to recompile the app as I was doing that. So the way that layout works is, obviously, it's bundling that XML inside your compiled app. But when you're running in the simulator, what it actually does is it finds the original source file on your Mac's hard drive and loads that version instead of the version that's bundled into the app. So what that means is that if you make changes to the source file, it can reload those changes without recompiling. And this is kind of my replacement for the WYSIWYG solution that Interface Builder gives you. So I didn't really want to have to build my own interface builder. That sounds like quite a lot of work. So instead of that, you can just basically reload your changes as you're typing them, and that gives you the rapid edit and testing cycle. So the other thing is, so this is a sort of liquid layout. I mean, it supports orientation. I'm not doing anything very complicated at the moment here, but I don't know up front how big that label's going to be. I want my positions to all be kind of dynamic and relative. And so, oops, okay, yeah. In order to support that, that's where these expressions come in. So these values I'm typing in here are not hard-coded numbers. They're code, effectively, that can be evaluated at runtime. And so there's little helpers in here like percentage, which refers to the width of the parent. And I can use actual math in here, and this will get re-evaluated every time the screen orientation changes or under various other circumstances. Now, you'll notice that Xcode doesn't do a particularly good job of pretty printing this for me, so I've got a plugin which will reformat this. Makes it a little bit easier to read. So you combine that to a keyboard shortcut, and you get some of the benefits of having a real editor. Okay, so let's do something a little bit more sophisticated than just a hello world label. I'll try and make a sort of interactive app so you can see a little bit more of what this can do. So first of all, let's bump that font size a bit. Now, you've probably seen other libraries that are similar to this. I mentioned React Native and other things before. So one of the key things I wanted to build with this is a solution that's for iOS developers. This isn't a cross-platform framework. It only does iOS. And although you're writing XML, the names of all of the classes and properties should be familiar. They're the same ones that you get in UIKit. There's very little sort of extra being added here. I don't have my own components. I've got a few extra properties like top and left just to make a layout a little bit easier, but it's generally just the APIs that you're familiar with. Oops, an error there. Oh yeah, thank you. All right. I don't know why it didn't say what that error was very helpfully, but I'll figure that out later. Okay. So that text field looks kind of horrible. So the default style of text field is kind of no style at all, and I can't for the life of me remember what the actual property is called. So I'm going to just have a stab at it and see if that's right. Style equals border, maybe? I don't know. Oh, damn. Sorry, there's a feature I wanted to demonstrate, but I've clearly broken it. So all right. Yeah, okay, I think it's... Got to make do. So the feature that I wanted to demonstrate, which unfortunately is broken at the moment, is that, yeah. Oh man. Right. How do I do this then? Oh yeah, okay. All right, that'll have to do for now. It's not very pretty, but we'll figure that out later. Right. So yeah, the feature I wanted to demonstrate, which unfortunately is broken at the moment, is that when you make errors, instead of the app crashing, you actually get a helpful error message. Unfortunately, the helpful error message at the moment is a red screen. Normally, there would be some indication in there of what you'd done wrong. However, you can fix it and reload without having to recompile the app again. And I've gone to great lengths to try and make sure that things that would normally crash won't. It's kind of like the opposite way that you would normally develop in Swift. So in Swift, we've generally agreed that programming errors should crash immediately. If they crash, then you have to recompile, and that's not ideal for this kind of workflow. So instead, the library will actually catch most of those errors and report them. So So as I mentioned, this doesn't use auto layout. It's kind of just, it does positioning based on frames, which makes it quite a lot faster in most cases. But you can use expressions like this, which kind of give you the same kind of flexibility that you would have with a normal auto layout constraint. So I can say that the position of this button is relative to any particular other control on the screen. I can use this previous alias to basically say relative to the previous or next control. I can also use this little helper called auto, which is basically use the intrinsic size. So let's just see if that's working. Okay. Okay. And you have access to layer properties as well, so if you wanted to get fancy, you can do stuff like add curved corners. So I could say, that's decent. There you go. It looks a little bit better. Can you make that out at all? I know it's really, the screen's really blurry. It's not gonna work. Okay. All right. So how do we handle interactivity? So this is a static interface now, but I've clearly got the intention to do some interactivity. How does that work? So that basically works the same way that it would do if you were using a nib or storyboard. And this is very much intended, at least on a first pass, to be a drop-in replacement for your nib file or your storyboard. So what I would normally do in this situation is I'd create an outlet for my label and my text field, and I'd create an IB action for my button. So that's exactly what I'm going to do. So create I just remember how to type Swift now. And what I want this to do is basically when I click say hello, it's going to change the label text to whatever I've typed. So okay, so now I just need to connect those up in the XML, and I can do that without recompiling now. So my UI labels outlet equals label. What do I call these? Okay, let's try that. Okay, so that works. I was about due for something to work the first time. So I wanted to demonstrate to you the cool feature where basically if you mistype any of this stuff, you get static checking. So like if I was to misspell the name of my method, then as soon as I reload, it's going to catch that. It has caught it, it just hasn't told you what went wrong, unfortunately. But that does actually work in the version that's currently on GitHub. All right, so what else can we do? Okay, so this is great, but this is kind of the old-fashioned way of developing. Like this is the way that you develop because we're using old Cocoa APIs that were designed for Objective-C. And it would be nice if we could use a sort of slightly modern approach, more modern approach to our development. So instead of using outlets, you can actually use a more sort of declarative data binding approach. If instead of reaching into the label and setting the text directly, we introduce the concept of state. So what I'm going to do So I've added this state variable, which is it's basically a dictionary of keys and values that can be used inside your layout. And I can now get rid of the label, which I was only using for setting purposes. I still need to keep the text field. If I rerun this now, so instead of my outlet for label, I can get rid of that. And hopefully that will now, yeah, that works. So now if I set the label's text instead of hello world, I change it to hello name, like this. So what this syntax is doing is basically saying just substitute the state variable name instead of that text. So now this should work the same way. But what's happening now is when I click the button, instead of just reaching in and changing that label, which is not a very kind of controlled way of doing things, I'm calling set state, and then that's triggering a re-render of the whole layout. That's done efficiently, so it knows what's changed to some extent and will only update the things it needs to. But that gives you much more control. Like you can make sure that the state displayed in your view is always self-consistent. So this, I don't know how we're doing for time, not great. Okay, so just one last thing I want to show you. There's a bunch of stuff I didn't have time to show you, but using dictionaries, again, is kind of a Objective-C way of doing things. It's not very elegant. It would be nice if we could have some sort of strong typing around our state, so like maybe our state might have a bunch of different variables in there, and it might be something that we reuse. Maybe we'd have like a view model type object. So we can do that. If we create a struct, and we'll call it something sensible. Maybe I'll just call it state. So I can get rid of this dictionary and replace it with a nice strongly typed object. And here again, I can say oops. And this works the same. And slightly inelegant aspect here. So this is where the real power of having expressions rather than just variable binding comes in. So we can make this, I shouldn't do that. We can make this logic a little bit more sophisticated and say something like, if name is nil, or if name is an empty string, then we should show name, otherwise show world. No? What did I do wrong? Oh, yeah, wrong way around. Got you. Okay. Yeah, that works. Okay. So hopefully you get the idea. So, I mean, you have to use a certain amount of discretion about how much logic you want to put in here. These expressions are all sort of pure functions. So it kind of saves you from yourself in trying to implement really sophisticated logic in here, but you generally still want to keep it pretty simple so that it's understandable. But yeah, I think that's about everything I have to show. So just to recap. So layout gives you a drop-in replacement for nib files in the form of layout XML templates. It's a human-readable, diffable format. So, like, I know it's writing XML, which is not everybody's favorite, but hopefully everybody could sort of, if you've got any experience with UIKit, everything in that file should have looked familiar. You have your rapid update test cycle. Instead of a WYSIWYG interface, you can just reload your actual views in your actual application. And I think that's more powerful in a way because you're dealing with real data. And it gives you runtime type safety. So unfortunately, I couldn't demo it there, but you get helpful errors when you make mistakes. And those are caught immediately when the template is loaded rather than wait until you press a button. Yeah, helpful error messages. There's a bunch of more sophisticated features I didn't have time for. So you can use templates, macros, and parameters. Those are all documented, but basically templates let you load. So if you have a view that you're reusing in a bunch of places, you can put that in its own XML file and then reuse it with parameters. Macros are basically like you can declare sort of a local sub-expression that you want to reuse in several different places. Parameters are, if you're using the templates feature, you can set parameters for your template that can then be set at the call site. Localization and accessibility, of course. Okay, I'm really low on time, but I'll just finish this and then I'll show you that. Yeah, over-the-air updates is the other thing. So there's not a lot of built-in support for it yet, but you can specify a remote URL for your XML and you can load that rather than a local file. It works with your existing native code base. You don't need to rewrite anything except your actual, your nib file, basically. And it works with your existing components. So there is some API for providing layout support for your views, but out of the box, they should just work pretty much anyway because it uses the Objective-C runtime to work out what properties should be exposed. And for me, it kind of fits the bill. So, if you want to position your view 10 pixels from the left of the screen, you say left equals 10. If you want to do something a lot more sophisticated, like, this view should be the width of its like immediate sibling times 3 plus pi or whatever, that's fine, you can do that too. So if you're interested in finding out more about layout, the top link there is the layout library itself. The one underneath is the expression library, which is a separate component that I wrote, which handles the expression logic. And you can use that. It's independent of UIKit, so you can use that on the server or whatever. And that's my email address, if you want to get in touch with me. Yeah, so I just wanted to show you quickly the localization thing. I know I'm keeping you from lunch, which is never a good idea. This is kind of handy that you can do this while you're debugging, but you don't really want to like hard code hello in your template. You want to use localized strings for that. So you could pass your localized strings through as state or constants, and that's fine, that will work. But there's actually quite a nice feature built in for support for localized strings. So hang on, I'll just... So I'll put... is this running? Okay, so the error message there would be telling you that there is no localized string called strings.hello. If I now go into my localizable strings file and add it, there it is, it's picked it up, and I can prove that this really is dynamic. Okay, and again, you should have hopefully noticed there's no recompile happening here. So it has support for localizable strings in the same way as XML. It can load that dynamically and let you make changes while you're developing. Okay, yeah, I think that really was everything. So.
Okay, thank you, Nick. Thank you for sharing with us another way of doing UI design. And okay, I see hands up already. Okay, last, we'll take in one question from you.
How do you handle table view cells with dynamic content? And how do you handle animations?
Yes, so and I've got a sample app which demos some of the features I didn't have a chance to talk about. So I do support table view cells and also collection view cells. They need a little bit of extra code support. So because basically the underlying sort of unit for one of these views is something called a layout node, which is like a sort of mini controller for your view. So if you're using table cells, you have to, here's a table cell example. And these, although you can't really see it because they're all the same height, these cells are actually dynamically sized based on the size of their content. So the way that works is I've just added some extension methods to UI table view that let you basically load a recyclable node from an XML file rather than loading it from a nib file. So hopefully you can see here, is that code readable? Yeah, so you've got register layout named rather than register cell from nib or whatever. You can also declare them inline inside your template. So in the table XML here, this is the XML for that entire screen. But down here you've got like a recyclable table header footer view. You've got a recyclable cell inline, and you can give it its reuse identifier. And then you just need a little bit of boilerplate code inside your actual table view controller that implements cell for row at index or whatever. That will then get registered and be reusable automatically.
Okay, thank you, Nick. Yeah.